2156, July 31st, 2026, right now marks 2,633 hours of progress on the global heart simulation. Currently, it's been learned how to track the state of voxels within a texture and then manipulate the volumetric fog's pixels based on the state of the voxel they belong to. And as a demonstration, by just simply toggling a Boolean value, it can override the visibility of every single voxel. And what this isn't doing is just simply passing a value to the material and then directly overriding it, but it actually reconstructs the UVs. And so what happens is that there's an array of voxels on the CPU, and then it stores the state in the fourth channel, which is visibility, and then inside the material it reconstructs the UV and then stores that UV or sends that to the texture that the voxel array is copied into, and then from that it retrieves the fourth channel, which again is the state of the voxel. And then if the visibility is set to 1, which is can draw given the Boolean, then it sets that extinction to be able to visualize the fog. And also another thing that's going on is the UVs are sort of being visualized by splitting out the UV into the red and green channel and then setting the color. And so basically what's going on is that allows to visualize the UVs, and so making that easy to see by the origin. It seems to be working correctly. The origin is at the bottom left, and that's the darkest pixels of the volumetric fog are there. Given that their color is based on the voxel they belong to, so the origin is the darkest. And then going away from that, one can sort of see the bands, and it's even easier to see the bands with the voxels being drawn. So I'm going to the top right. Voxels are the brightest in that region. So the intention going forward, now that it's basically been figured out how to voxelize the fog, is to obviously go and implement the fog of war, where the voxels are looped through and then some are hidden. As what this allows the program to do, unlike normal fog of war, is to have height-based fog of war and also track the state of a voxel, and the voxels can be used to have fog of war that leaves a persistent trail throughout the environment. And most implementations of fog of war is a flat texture above the level, but this takes height into account, so that could be used to also have different areas of different elevations receive fog of war correctly. And so the intention going forward is to actually look into optimizing something which is not the voxelization process itself, if that seems to be very fast, but the current bottleneck is actually just drawing them. As what seems to be occurring here is that the Unreal Engine draws debug boxes, but it seems that they're not being included as they're taking performance. And also it seems that there's a lot of overlap in the points. So what would probably be more efficient is having a function that creates a singular mesh where all the points are belonging to that mesh, so there's not as much overlap, and then instead of whatever is going on here where it seems to be not including different boxes, it would include the parts of the mesh that are outside of the camera's view, and so the intention going forward is to look into implementing that as well as leaving a trail behind, which should be pretty simple now that the state of the voxels are being tracked. And so the intention going forward is to continue implementing logic for fully 3D fog of war in Unreal Engine. And it's quite good that this is working, as this was originally took months to create inside Unity Engine, and in just a couple of days it has been basically ported over to Unreal Engine, as it was easier to work with the fog in Unreal Engine. And so the intention going forward is to continue implementing fully 3D fog of war.